Okay, so we're trying to do this problem about making an open-sided box out of a piece of paper by cutting squares out of the corners. So it was brought to my attention that if we cut out really little squares, that this might be kind of hard to see. So I'm going to do that. So if we cut out, I'm cutting out squares that are like, what, 1/8 of an inch or a little bigger? 3/16? Yeah, I said don't do this, and here's the reason why. Okay, they're like a quarter, whatever.
Oh, and yeah, I'm thinking a 1/4 inch.
Okay, so I cut those little tiny squares out of the corners, right? And now to make this box, I should take the kind of tabs and fold them up, right?
Oh, that kind of thing.
Yay. So this is going to super suck.
Wait, why are you doing this so small again?
Well, because I kind of wanted to illustrate the ends of this. So, here. Gabe, can you finish folding this? Do a good job, okay? And now I'm going to make ones that are bigger. It's okay, it's just an approximation, buddy. So these are what, 1.5 or maybe 2 inch? Oops. So these are basically biggish. Okay. So these ones are easy to fold up. And this is like really a crappy job that I'm doing. Okay, so there's my box, right? This one has some kind of like vaguely reasonable volume. Like if I filled this with rice, there would be what, 2 or 3 cups of rice there? You guys recognize cups are a volume measure, right? Cool. Okay. Then if we did, sorry. So then if we did bigger squares, right? Like the biggest square I can feasibly get out is the one where I do this. I just cut down the middle, right? And then cut in. And now there's no tabs to fold up, so I'm just kind of done with that. You guys see that? So this one has no volume. The heights to fold up are 0. This one, right? Put it down, put it down. It's got one of the baby geese running around. All right, so this one has really little volume, right? Because the heights are small.
Yeah, man.
I guess this one has really little volume, actually, not because the heights are small. Maybe I should do that one again. So what happened there? Oh, don't use that. So what happened there is I cut up big squares, right? So I'm going to not quite. So if I cut out squares that are not quite the whole thing,
Oh, you get it. The width of the sides becomes 0.
yeah, the width of the one of the sides becomes pretty small. Yeah, pretty much.
Had a great time.
So you guys see this kind of like tall, narrow box? Is the volume of this box bigger or smaller than the volume of that one? Yeah, it seems pretty obviously smaller, right? Certainly if I made it narrower yet, it would be even smaller, right?
Find some kind of vertex here.
Yeah, so I just got to try to find a happy medium here, right? Yeah, we did this one a little bit already. So the sides I think I want are to know, let's see. So here's my sheet of paper, right? If I call the side I cut out x, then the height is that x value, right? And the width is what?
The length of the paper minus 2x.
Yeah, perfect. So it's the width of the paper minus twice x. So that'd be 8.5, right? Minus 2 x's. And the length of this thing, right,
Then minus 2x.
is going to be the length of the paper, so 11 minus 2x. And then, of course, the volume of the whole thing in terms of what you cut out, right, is the height, the length, and the width multiplied together.
Okay.
Right, so you get an x times 8.5, and I really shouldn't have used a mixed number there because mixed numbers are a bad idea, minus 2x, and then times 11 minus 2x. And then this is going to be a cubic, right?
Yeah. Zero product rule anything? To do something?
Yeah, so I could zero product rule this thing, and what am I going to find out if I zero product rule this? I'm going to find out when the volume is 0, right? So that's going to correspond to the one where I didn't bother to cut out squares, right? This one, where there aren't any tabs left to fold up. And another one that makes even less sense, where I cut it in half the long way and throw all the pieces away anyhow. Okay, see that? So if I plot this thing, this is a cubic, right? And I know it goes through 0, 0, and I know it goes through 0 again at half of 8.5 by 11. Or sorry, at half of 8.5. So out here at 4 1/4. It goes through 0 again. So my best guess at this kind of sweet spot, like this guy, is probably what?
Between those 2 points?
Yeah, it's probably roughly halfway between 0 and 4 1/4.
So like 2 1/8.
Yeah, so like 2 1/8, which is basically what I did for this one. So that's probably about the best I can do. Is that actually the best I can do?
No.
Graph it.
Probably not. I want to graph it to find that vertex because it's not right in the middle. It's offset to one side or the other. Cool? So calculator or calculus. Either way we'll find you this.
Which side would it be offset to?
That's a good question. Let's see. So it's probably offset to the towards 0 side. But that's my best guess, and it's just that. It's a guess.
Okay.
Cool? Question, Steele? That the paper examples help?
Yeah.
Yeah, a little bit. The third one's weird, right? The third one's like really hard to make.